Pawar. I handle the systems engineer role in VMware. I'm based out of Mumbai. It's been a year now. I'm working on VMware products and technologies. Now, what we are doing, we are giving the capabilities of these components like servers, storage, and network on a software layer. That is what the term is, software-defined data center. How we do it, what components does it have, we'll see it throughout the session. We'll run through few of the slides which are a bit technical. I don't want to waste much time now, but I'll be available after this session. You can catch me anytime. Okay, so moving ahead. So this is what we started. In 2000, we announced our own hypervisor, that is VMware ESX, which is server virtualization. So server virtualization is a simple concept, consolidating all your physical servers on fewer servers. That is how we started. 2011, we realized that it's not only about the servers. Rest of the physical components like storage and network are also creating a bottleneck when you talk about the quicker response, quicker delivery of the applications, right? So that is where we focused on software-defined data center. Software-defined business, we have seen a lot throughout the day, but if you are feeling that my organization is not ready towards software-defined business yet, I can sense that many of you may be feeling that I am not ready yet for the software-defined business. I am still okay with my physical infrastructure. I want to give you a small example. A customer, the name is Chai Point. Anyone has heard about it? Chai Point. If you go to airport now, you'll find the stalls by the Chai Point. We started with the small company. It's the bread and butter is completely tea. No other products. They are mastered into the tea. Now how they started? From the small tapri. Now they do have a lot of stalls on each and every airport. They take orders from the commercial offices. They do have their own dispensers installed at the offices, and they have installed IoT as well, whereas they can manage what is the consumption of the tea, what is the flavor consumption, what snacks they are getting out of that dispenser, and how the rate is. So IoT is helping the business to expand, right? So it's not only about the specific segment, the digitization, digital transformation, it's for the chai walas also. So this is a good case. If you're thinking we are not yet ready, but every now and then you may think that the world is moving towards the digitization. So this is how we set up. This particular session, I'm not talking about any of the software-defined business. We'll focus on SDDC only, what we do and how we do. Moving ahead, SDDC, the basic core component is VMware vSphere. For those who understands vSphere, who understands the technology, it's like a piece of cake for you. But for them who have newer to this technology, I would like to spend a few minutes on this. So, if you see the physical infrastructure, you have around, let's say, 20 odd physical servers with traditional applications running on top of that. It can be database application, it can be SAP also, right? So, whenever you see the business critical application, the utilization of the resources in any hardware, in any server, there are 4 components: CPU, memory, hard disk, and network. We call it as compute, right? So, in business critical applications, you will see 40-50% of utilization majorly. For non-business critical applications like Active Directory, domain, right, antivirus, all these are not that critical applications. You'll see hardly 2-3% of resource utilization, but you have allocated more than that, right? So what virtualization is bringing, we can utilize these resources at the optimal level. That is one. Second, if you have huge set of servers, let's say 20 odd servers, to manage those servers, it's a different task. You have to do OS upgrades, patching, management. For an administrator, it's a tedious process. Third thing, power cooling consumption, rack utilization. It's again an investment for the organization, right? So what VMware did, so this is, for example, your server. In normal era, in physical infrastructure, it's 1:1, one application, one physical hardware, and you're installing operating system on top of application. So what we are doing, we are just decoupling your application and operating system from the underneath hardware. Okay, so you take any hardware, install VMware ESX hypervisor on top of it, and decouple your OS and application and run it as a virtual platform. What does it mean? So this is a traditional view. You have Exchange server running on Windows, you have Oracle, you have SAP, one-to-one mapping. Once you do a virtualization, all the resources, as I said, like CPU, memory, and storage, network, are acting as a pool, and you are running these applications as a virtual instances on top of your physical servers. And let's assume you have 10 physical servers. After consolidation, it may come up to 10 physical servers only. 100 physical servers to 10 physical servers, and all the applications running as a virtual machines. Clear? So this is what the basic virtualization is. So what we did, we just partitioned the underneath the hardware from the application and operating system. We isolated the virtual machine from one another. It may happen like, if I am running the two virtual machines on the same resources, what about the isolation? Am I going to use the same resources? No. Every virtual machine is isolated from one another. You can allocate your resources, and hypervisor is intelligent enough to manage those resources within the virtual machine. Encapsulation. So you are basically encapsulating a virtual machine. So virtual machine is nothing but set of files enclosed in a folder. So it's just like copy pasting a file. You can also take a backup of it. In a physical environment, how you're backing up the data? You're backing up the complete server, right? If that physical server goes down, you have to take a bare metal hardware, install an operating system, install a OS, then recover the data if you have backed up the data, or else you have to recover the entire bare metal recovery backup, right? So it takes a lot of time. When you talk about virtual machines, it's just a piece of folder. You have to take a backup of it. You can take snapshot, you can take clones, you can do anything what you can do with the software, right? So this is what the encapsulation gave, and it's completely hardware independent. For example, if you have one Dell server, one IBM, one HP, we can still work, right? It has no dependency on the hardware, apart from few technical prerequisites what you need to check, but keeping it aside, rest of the independent hardware you can play around with that, right? So there is a lot of modifications we have done and enhancement we have done into VMware ESX. It started off with 4.x, now we are into 6.5, which is the recent version. We have introduced a lot of new features within the ESX environment. One is encryption VM. Any organization who is security centric can encrypt the virtual machine with any third party keys. They can do that. Second thing, they can have a dynamic resource scheduler, as in, if suppose I have consolidated all my infra on, let's say, fewer number of servers. There are features like vMotion, HA and all that, right? So if suppose at one fine day, at a month end, one of my ESX server, one of my physical hardware goes on a big utilization. So the virtual machines running on that server are utilizing the resources at the optimum level. Now what to do? It will throw you an alert saying that you need to migrate few of the virtual machines to other server, right? But practically, if you are not available in the office, then what? Then this DRS feature automates this stuff. So it understands I have 3 servers, out of which one is overutilized, one is underutilized. I can manually migrate, I can automatically migrate the virtual machine from this server to this server. So this is an automation which we have evolved into a DRS feature, which is again a feature which was there in earlier releases also, but we have added a predictive DRS on top of it. You have proactive HA now. HA, anyone understands HA? HA is in one server goes down, all VMs will get restarted to the other server, right? So when you talk about proactive HA, we have an integration with vCenter, which is our management console, to a tool from the hardware vendor. So just like OneView is there, System Center is there. So we take a probe from them saying that the resources, hardware resources like drives, motherboard, power is okay or not. If it is not okay, it gives the trigger, and vCenter takes a proactive action to migrate this virtual machine to other server, keep it in the maintenance mode and let it fail. So practically HA scenario is a rare incidence now. So all these new features we have added into 6.5. So it's not like VMware is not focused on ESX anymore. We are focused on rest of the products, but still there are enhancements which are happening over the versions. So this is about ESX. Moving ahead, software defined storage, because when we talk about software defined business, If only virtual machines are virtualized and rest of the components are physical, you are still going to see the same challenge. Because if I want an application, I have to go back to storage team. What IOPS, what capacity, on which tier you want to run data, what is the performance requirement, all that aspects you have to consider. Can anyone tell me what is the use of storage? Why do people use storage?
Data storage?
To put a large size of data.
Okay, I can phrase it capacity.
Yeah,
so when you talk about internal drives of servers, you have limited capacity. But when you talk about storages, you can scale up the capacity. You can add enclosures on top of enclosures, right? So you can scale up the capacity. That is one. Wonderful. Anything else? Why we precisely go for storage, not with the
to centralize the data.
Centralizing the data. If you want to create any cluster or something, you want a shared storage to centralize it, right? Availability. If any of the controller goes down, you have redundant controller, you have RAID, you have a lot of other stuff when you talk about the data protection. Availability. Great. So major thing is performance. Because storage has something called as integration of SSDs and the normal drives, right? Whereas you can get a cache out of the storage. So these are wonderful capabilities of storage: performance, availability, capacity, and there are add-ons like replication, snapshots, and all that stuff, right? But there is a flip side to it. Let's assume you have virtualized your infrastructure and you have a shared storage. Any shared storage, it can be EMC, it can be NetApp, it can be any vendor-specific shared storage. When you go with any vendor, every model has a certain limitation. Take an example, ENX 3300. It has a limitation of certain capacity, certain IOPS. If you reach that limit, then what happens? You'll have to add the new model and do a data copy. Few of the vendors also supports data in place upgrades, but most of them supports within the series. You have to copy the data. That is one. Second, the prices are generally dictated by the vendor. If suppose you are going with EMC, you want to upgrade your SSDs, you want to upgrade your enclosures, the prices are dictated by the vendor. You are locked with that vendor. That is one. Second, when you create a volume out of storage and run virtual machines on top of it, the IOPS are shared by that volume, right? Because you are not creating one volume for one virtual machine. You are sharing the volume, right? So IOPS are again shared. Again, the processes are complex. You have to go to storage admin, do the FC switch configuration and all that stuff. So while getting into all these issues, we understood there is a requirement of storage, but at the same time there is a flip side to it also. Now what we did, with a simple concept of server virtualization, what was that? Abstraction from the hardware, giving those capability on a software. Right? We did the same thing. We took x86 commodity servers. It can be of any brand. You take it, you connect these servers with 10G backplane, just like here. There are 3 servers connected with each other through 10G cluster. Recommended is 10G, it can be 1G also, but recommended is 10G. It can be copper, FC, both are supported. Put the internal drives in those servers. Now, what are the capacities we have? Capabilities we have from storage? Capacity, right? You can add 64 such nodes within one cluster. Okay? So, practically the capacity you can get out of it is in petabytes. Second parameter was performance. Minimum you should have one SSD in each server which will act as a cache, and rest of the drives can act as a capacity. Okay, and the third crucial point was availability. In storage you were doing RAID, right? Over here there is no RAID. It's a complete JBOD. What we are doing, we are presenting these number of drives to a vCenter as a JBOD. Okay, and we are building a policy-based management on top of virtual machine. Now, what is that? Okay, so before moving to policy-based management, this is how we can position vSAN or a software-defined storage. You can either go with all flash within the servers, or you can go with hybrid, one SSD and number of hard drives. That is possible. There are 2 models to go with it. One is bring your own servers, you suggest your servers, you want Dell, you want HP, you want hybrid of it, that is also possible. Or there is an appliance with Dell EMC and VMware jointly engineered called as VxRail. Okay, so VxRail is an appliance which runs with the vSAN as a secret source. Okay, so this is how we can procure the products basically.